Okay, so this video is covering surface area of prisms and pyramids. The first is the definition of lateral area, which is the sum of the areas of the lateral faces. And surface area or total area, these are meaning the same thing. When you go through the notes, SA is going to represent surface area, TA is total area. Again, these are the same thing. And that would be the sum of all the areas of all its faces. So the lateral areas and the base. So let's take a look at these three different solids here. The top one is actually a rectangular prism. Again, remember from 11.4, to name a prism, you use the shape that is that you have for the base. This is made up of 2 rectangular bases and 4 lateral faces. The shape over here to the side, this is a triangular prism. Notice you have 2 triangles here. You've got the front triangle, and then you have the one that's here in the back. So whatever shape you have 2 of, that is your base. And then notice this is composed of 2 triangles and 3 rectangles. And then the shape down here, this is actually a hexagonal prism. Notice we have 2 hexagons, one here in the front and then one back here in the back. And then there's 6 rectangles for the lateral faces. Now again, remember, sometimes when you're presented these prisms, they're not sitting the shape on its base. And that's the case here for the triangular prism. Notice it's sitting on one of its lateral faces, as well as the hexagon. So just be careful when you're trying to identify the base shape. So the lateral area, we can do this if you do it possibly how you learned in middle school, where you're just going to find the area of each face separately and add them up. That's one way. The faster way is to find the perimeter of the base and then multiply it by the height of the prism. And that will give you the total lateral area of all of those rectangles. And then to find total area, you would take your lateral area that you found up above here. And then remember, you have 2 of this same congruent shapes, which are your bases. So you would find the base of one of them, or the area of one of the bases, and then times it by 2. So again, remember LA, this is really perimeter times height. And then here, this capital B represents the area of your base shape. So let's try an example. We have a picture here of a rectangular prism. And the way that I can tell that this is a rectangular prism and not a cube is notice the dimensions. They're not the same. If this were this cube, all of those numbers would be the same number. So this is a rectangular prism. So again, if you're asked to name the type of solid on your test, again, you would use the base shape. So this is a rectangular prism. And here, when you have a rectangular prism, you could choose which rectangle is your base if you don't want to use the one that it's sitting on. I'm going to actually use the one that it's sitting on. So let me just go ahead and draw in the sides that we can't see. Draw in some dotted lines. So this would indicate this is my base shape here. So the perimeter of this I can find by adding, and remember, opposite sides of a rectangle are congruent. So my perimeter of my base shape would be 4 plus 4 plus 2 plus 2, giving me a grand total of 12 centimeters. So the P in that first box is standing for the word perimeter. The B in this second box, this stands for the capital B, the base. And what it is we're finding the area of that base. And we can see it has a dimension of a base and a height of 4 and 2. So base times height, or length times width. So 4 times 2. And the area of the base is 8 centimeters squared. Remember, area is always the unit squared. Now for the lateral area, since we already know the perimeter, we're going to use the formula perimeter times height. Again, you could go back and you could find the area of all of those 4 rectangles on the sides, the front, the back, the left, and the right. Add them up and you could get the lateral area that way. But it's a lot easier to take the perimeter, times it by the height, and the height of my prism is the 6. So 12 times 6, and it's 72 centimeters squared. And yes.
What does it say where it's the base? It says A as
area. That says area, sorry. That word right here?
No, the other one before it.
Base? B-A-S-E.
Oh, okay. And why would you multiply it by 2 and not 6?
Because the base shape is a rectangle down here and it's 4 by 2.
Okay, thank you.
Now, for total area, we're going to use the formula. Remember, we have 2 bases, and then we have the lateral area. So my base area was 8, so 2 times 8. My lateral area is 72. So 16 plus 72, 88 centimeters squared. So probably in middle school when you did rectangular prisms, they probably taught you something like this. Length times width plus width times height plus height times length, something like that, or any version of that. You can do this as well. And then there's like 2 in front of all of this because you have 2 of each. So there should be a 2. So it could be, and some formulas did something like 2 times the length times the width plus 2 times the width times the height plus 2 times the height times the length. This is probably how you learned it in middle school. Again, you can resort to that if you see something like this on a standardized test. Everybody good with example 1? All right, let's try example 2. This is a triangular prism. Remember, prisms are flat on the top and the bottom. Pyramids come to a point. Now, I know this is kind of hard to see, so let me go over some of these lines here. So these lines that I'm going to outline in black, these are going to form the lateral faces. The base here is a triangle. It's what I have two of. Now, this right in here is a 2.8 for the height of this triangle. And I can say that this is 3, this is 4, because remember, the 2 triangles are congruent. So the top and the bottom are 2 congruent triangles. The 6 over here is the height of my prism. So let's go ahead and complete the table for this one. So again, the P here represents perimeter of the base. That's what the P represents. Remember, this capital B is the area of the base. This is the lateral area, the LA. And then the TA or SA, this is either total or surface area is what we're going to be calculating in this 2 boxes. So for perimeter, all I need to do is add up all the sides of that triangle. So I'm going to be adding 3 plus 4 plus 4, and it's 11 centimeters for the perimeter of the base. For the area of the base, it's a triangle. I have my height here, the 2.8. So the formula for area of this base is either BH divided by 2 or 1/2 BH, because it's a triangle.
Excuse the interruption. Can you please send Samuel Gonzalez to Student Services?
Okay, so the base shape is a triangle, so the formula for area of a triangle is base times height divided by 2, or 1/2 BH. So I'm going to go ahead and fill in my numbers. So my base is 4, and my height of the triangle is 2.8. So 1/2 base times height, and this gives me 5.6 centimeters squared. Remember, the formula for lateral area is perimeter times height. The perimeter was 11. The height is 6. So it's 66 centimeters squared. For total,
I'm so sorry.
and for the total area or surface area, remember you have two bases, two triangles, a triangle on the top and the bottom, and then the lateral area. So by filling in this chart, it gives us the answers ahead of time. So we would do 2 times 5.6 plus 66, 11.2 plus 66, 77.2 centimeters squared. Now, probably in middle school, they probably just told you, find the area of each of the triangles, find the area of the 3 rectangles, and add them all together. Again, you can do that. For any surface area of any solid, that's the formula you can do. You can just find the area of each face and then go back and add them all up. This simplifies things a little bit, and it makes it the problem a little bit easier. Yes? The next slide has a hexagon. Now, I know when I used to teach middle school and we would see questions like this, they wouldn't have taught you the formula that you guys learned. And the formula for your hexagon, remember, is area equals 1/2 apothem times number of sides times side length. What they did when I taught middle school is they would already give us the area of the base. And then from there, you would find the lateral faces. However, we have now learned how to calculate the area of a hexagon. And what was nice here in this picture, they gave us everything we needed. They gave us the n, which is 6. They gave us the side length, which is 8. And they gave us the apothem, which was 7. So I didn't have to draw a triangle here. So I'm going to find the area of the hexagon, which is my base shape. So my base is a hexagon because this is a hexagonal prism. So my area of the base shape is going to be 1/2. My apothem is 7. The number of sides is 6. And my side length is 8. Once I multiply all those numbers, I get 168 units squared. And that's the area for one of the hexagons. And I have 2 of them. Now, to find the lateral area, remember that formula. So remember, for total area, the formula is 2 times the base area plus the lateral area. So I already did the B. That's this 168. I need to do the LA. Lateral area is perimeter times height. I know all sides of my hexagon are going to be 8. And I know that, let's see, what else do I know? And I know that there are 6 sides. So my perimeter, let me do that over here. Perimeter is going to be 6 times 8. So my perimeter is 48. So my lateral area is 48. And my height of the prism is the 6. Because again, this prism is not sitting on its base. So once you lay it down onto its base, you can see that it has a height of 6. So my lateral area is 288 units squared. Now that I have the lateral area and the area of the base, now I can do surface area or total area. So 2 times the base area plus the lateral. My base was 168. My lateral is 288. 168 times 2 is 336 plus 288, giving me a total area of 624 units squared. So again, if you prefer to find the area of the 2 hexagons and then the 6 rectangles, you can do it that way as well. Now we're going to move on to pyramids. And again, you can do the same thing. Whatever shape you have on the base, you would find that area. And then if it's a square pyramid, then you would find the area of the 4 rectangles which form the lateral area. If it were a triangular pyramid, you would find the 1 triangle base and the 3 triangle tops. So let's go ahead and take a look at the pyramid. Now, these 2 methods that are listed here are only for regular pyramids. And when I talk about a regular pyramid, if it's a quadrilateral, it's going to be a square pyramid. If it's a triangle, then that base shape will be an equilateral triangle. If it is not a regular pyramid, then you would just have to find all the faces separately and add them up. So method 1 is to just find the area of one of the lateral faces, and in this case it's a triangle, and then multiply it by however many triangles you have at the top. So if it's a square pyramid, we would find the area of one of those triangles on the sides and then times it by 4. The other method would be to use the formula 1/2 perimeter times L, where L represents the slant height of the pyramid. Notice in my picture here, the slant height goes down the side of one of the triangles, whereas the actual height of the pyramid is straight up to that top vertex. So be aware of the location of the slant height and just the height of the pyramid. So let's go ahead and try an example. Now, before that we do that, let's talk about total area. So for the total area, you're going to do the previous slide and either use method 1 or 2 to find the lateral area, then find the area of your base, and then add them together. Now again, if your pyramid is not regular, then all you're going to do is find the area of all the triangles on the top, and then the shape of the base, and then add them up. So let's try an example. So here they're telling us we have a regular square pyramid. Now this one's a little tricky because we have to do Pythagorean Theorem to find some of these heights. So let me go ahead and draw a pyramid. I guess that's good enough. Okay, so it said it's a regular square pyramid with a base edge of 6. So that tells me all of these are 6, and then even these back here. And then it also has a lateral edge of 5 centimeters. Now the lateral edge goes down the side, let me do it maybe in green, the side of the lateral edge here. So that's going to be, no, that's the slant height, sorry. The lateral edge is this over here. This is 5. Now, to find the slant height, which goes down the side of the triangle, we're going to have to do Pythagorean Theorem. Notice, once I combine the slant height with this lateral edge and then half of this side length of this base edge, I can form a right triangle. So once I draw down the slant height, it's going to split this 6 into 3 and 3. And now I'm looking for the slant height, which we'll call L. So I'm going to do Pythagorean Theorem. L squared plus 3 squared equals 5 squared. Now some of you are going to recognize that this is actually a Pythagorean triple, but if not, let's finish the Pythagorean Theorem. Move the 9. L squared equals 16, square root it, and the slant height is 4. For the lateral area, remember we're going to find, there's 2 methods. For this example, I'm going to find the area of one of the triangles and then times it by 4. So because I just found that slant height, which is going to be the height of my triangle, I'm going to be doing for the lateral area 1/2 base times height times the number of triangles, which is 4. So my base of my triangle is 6. The height is 4. I just calculated it. And then I have to multiply it by 4 triangles. So once I multiply all of these numbers, I could take half of the 6, make it 3. 3 times 4 is 12, times 4 is 48. So the lateral area, or the area of the 4 triangle sides, is 48 centimeters squared. For my base shape, it's a square, so I'm just going to do 6 times 6, and it's 36 centimeters squared. For total area, what we're going to do here is we're going to find the area of the base, which we did, plus the lateral area. So my base is 36. My lateral area was 48. So my total area is 84 centimeters squared. To find the altitude, which is really the height of our pyramid, that is going to be from the vertex down to the middle of the base. Again, I need to do another right triangle here. So I can go ahead and draw the leg over here to the side, which is going to be half of the 6. I'm looking for the H. I'm going to use this slant height as the hypotenuse. So for the length of the altitude, I'm going to do my height plus 3 squared equals 4 squared. 9 equals 16. Gonna subtract 9. Height squared equals 7. Height square root it. And the height of the pyramid is the square root of 7. Two more examples and we're done. Next one is a regular triangle. So regular triangular pyramid. It's giving me a slant height of 9. So remember, the slant height comes down the side of the triangle. And a base perimeter, look, they've already given us the perimeter calculated, and that perimeter is 12. So the formula I'm going to do, I'm going to use method 2 for this one. So lateral area is equal to 1/2 perimeter times slant height. Perimeter was 12. Slant height I got from the problem as well. It's 9. Multiply those 3 numbers, 54 centimeters squared. Now for my base area, remember it's a regular triangle, so this base shape is an equilateral triangle. So I need to draw down and find the height, or this altitude here. Remember, an equilateral triangle, each one of these angles is going to be 60. Once I drew in that height, it splits this angle here into 30 and 30. I now have a 30, 60, 90 right triangle. Remember, across from the 30, we could say that's x, 2x, and this is x root 3. Well, in my triangle, they told me all of these sides added up to be 12. So that tells me all of these sides are 4. So all of these have a 4 here on my base shape here. So once I put it back in here to my special right triangle, if this one is 4, then I know this is 2 and 2. And then my height, which is what I was looking for, is going to be 2 square root 3. So the base area is going to be 1/2 base, which is 4, height, which is 2 square root 3. Multiply these numbers. Now I could simplify this. And then the base area is going to be 4 square root 3. So this is my base area. And now for total area, it's just base plus lateral area. So 54 plus, oh, sorry, I'm doing this backwards. Base area is 4 square root 3. Lateral area was the 54. Now, if it says to leave it in simplest radical form, this is how we'll leave it. However, if the instructions say round to the hundredths place, we would figure out what the square root of 3 is, and this would give me 60.93 centimeters squared. So just make sure you read how they want you to leave the answer. One last example. And again, example 6 would be something you did in middle school where it's not regular. They would just tell you, find the area of the 4 rectangles on the top and then the rectangle on the bottom. So when it's a rectangular pyramid, the formula doesn't work. So we can't use the formula. This is a rectangular pyramid. So what I'm going to do for this one is for my total area or surface area, however you see it, we're going to find the area of the base, and then we're going to add the area of the front triangle plus the area of the back triangle plus the area of the left triangle plus the area of the right triangle. Now keep in mind the left and the right are the same triangle, and so are the front and the back. So once you find one of them, you could just times it by 2. So for my total area, the base shape is that rectangle, and the formula for area of a rectangle is base times height, so 11 times 5. My front triangle is here, so I'm going to do that for both the front and the back. So the area is going to be 1/2, 11 times 10.3. This is for front. This is also for back. And then left will be 1/2, 5 times 11.4. And same thing for the right. 1/2, 5 times 11.4. I'm going to go ahead and do all these calculations and add them up. So for the base, it's 55. For the front, 56.65. For the back, the same. For the left, 28.5, for the right, 28.5, giving me a total area of 225.3 yards squared. So again, whenever you're doing surface area for a prism or a pyramid, you could get away with just using the basic formulas for triangles and rectangles or squares. Find all the areas of the faces separately and then go back and add them up. Or you can use these formulas that I just taught you, which will definitely simplify things when you see something like this on an SAT or an ACT. Yes?
Can you go back to the slide that has example 4?
Yes.